Hi, in this session, we're going to take a look at factoring polynomials. And the goals for this video is to take a look at how to factor out the greatest common factor of a polynomial. We call it the GCF. We're also going to factor by grouping, then factoring trinomials, three-term polynomials, factoring the difference of squares, and then factor perfect square trinomials. Okay, let's take a look at our first example. We're going to call this problem 1a, factor out the greatest common factor. Now, if you have two terms like this, you have 10x to the third minus 4x. You want to factor out the greatest common factor. If you think about, if you break down 10x to the third to its basics, so 10x to the third, we can factor it as 2 times 5. Now, x to the third is x times x times x. Then the minus 4x, we can break that down to negative minus 2 times x. If we circle what they have in common, they have a 2 in common. They also have a single x in common. So we say that the GCF, the greatest common factor, is 2x. If we do open parentheses, after we factored out or divided out 2x, we kind of factored out the 2x on the side. We're not canceling, I'm just saying that we're factoring it out. What's left is this 5x term, or 5x squared, minus the 2 term. And so we got 2x parentheses 5x squared minus 2. We're done with the factoring. If you're not sure, if you want to double check, did I do the factoring right? You can distribute to 2x times 5x squared, get 10x to the third. So this is just checking our work. Then 2x times negative 2 is negative 4x. Do you need to check every time? Not always, but you can check, once in a while, or if you feel like you're not 100% sure about your factors. Remember, this 3, this 1, and this 2 have to add up to that 3. We took a look at that in the previous video under polynomials. Okay, so let's take a look at the second one, or we're calling this problem 1b, 18x to the fourth plus 27x to the third plus 9x squared. I'm looking at the x terms here first. The x squared, it looks like they all have x squared terms. And if we look at the numbers 18, 27, and 9, it looks like we can factor out a 9. So we can factor out 9x squared. Something I like to do, although you don't have to do it this way, is just remind myself what I'm dividing by. 9x squared, 9x squared. So if I divide 18 by 9, it's going to give us 2. X to the fourth divided by x squared. With the division of x terms, you're going to subtract the exponents. So we have x squared plus 27 divided by 9 is 3. X to the third divided by x squared is x, plus 9x squared divided by 9x squared gives us a 1. So here we have 9x squared times 2, or parentheses 2x squared plus 3x plus 1. Okay, so we factored out the greatest common factor. Let's take a look at factoring by grouping. We call this method factor by grouping. Usually when you have 4 terms like this, you have 3x to the third minus 2x squared minus 6x plus 4. And we group the first 2 terms together and the second 2 terms together and factor out the greatest common factor from the first 2. So if you think about 3x to the third minus 2x squared, the greatest common factor you can factor out is just x squared. And if you factor out an x squared from 3x to the third, it leaves us with 3x minus 2. From negative 6x plus 4, you can factor out a negative, 2, leaving us with 3x, because negative 6x divided by negative 2 is 3x. 4 divided by negative 2 is minus 2. Again, if you're not sure, always just distribute to check, see if you get this step before. Okay, from here in this step, you always want to check to see your parentheses are the same, and it is. Then we're going to put that in one set of parentheses, 3x minus 2, and the other one, the other set, x squared minus 2. And here we're done with the factoring. We broke it down, and you can check by FOIL. And you can review, if you haven't watched that recording, you can go ahead and watch the recording for polynomials to go over the FOIL process. Let's go over factoring by grouping again, another example. More examples, I think the better. So grouping the first two, the second two, x to the third plus 5x squared, we can factor out an x squared term, leaving us with x plus 5. Negative 2x and negative 10. When there's a negative, you always want to factor out the negative. Factor out negative 2, dividing negative 2x by negative 2 is positive x. Negative 10 divided by negative 2 is positive 5. All right. Again, it's the same, so let's put these guys, x squared minus 2, we're going to put that in one set, parentheses, x plus 5. And you can check your factors by using the FOIL process and checking to see if you get the original problem back. All right, let's take a look at number 3a. Now factoring a trinomial. So these three terms, this example, it's the leading coefficient or the number in front of x squared is 1. What we do is we multiply the leading coefficient with the last number. And that's going to give us negative 40. And then what I do is this cross method where we put the middle term down here, 3. You think about what terms multiply to negative 40 and add to 3. So sometimes it's kind of hard to just tell what that is. So you can break down 40 into 1 and 40, or do a factor tree of 2 and 20. I don't think 3 goes into 40, so we'll skip right to 4 and 10, then 5 and 8. So here are all the different ways of multiplying to 40, and I'm trying to make a negative 40 and then a positive 3. So it looks like we grab 8 and 5 and then 8, and make the 5 negative. Negative 5 times 8 is negative 40. Negative 5 plus 8 is positive 3. So those two pairs of numbers do that for us. And then when a leading coefficient is 1, we can just simply use that as our factor. So this factor says x minus 5x plus 8. So you can kind of think of factoring as a reverse FOIL process. So if we have these factors, that's the answer. That's the final factors. You can check by doing the FOIL process. So we'll just do that once here. We have x times x, which is x squared. Outer is x times 8, which is 8x. The inside is negative 5x. Negative 5 times 8 is negative 40. The middle term is 8x minus 5x, which is 3x. So we have x squared plus 3x minus 40, and it checks out, right, as the original problem. So we know our factors are good to go. You don't have to do this every single time, but it's good practice too. Let's do another example where the factor is the leading coefficient is 1. So again, 1 times 49 is just 49. Once I got big cross, we write the middle term below. We're thinking about what times what gives you 49 and adds 14. Well, we know 7 and 7 times is 49, and 7 plus 7 is 14. So when the leading coefficient is 1, we can just put the factors as x plus 7, x plus 7. And then because they're the same repeated factors, just condense it into x plus 7 squared. Always remember to simplify it all the way. Okay, let's take a look at the next one, number 4. Or no, number 3C, I'm calling this. Factoring the trinomial when the leading coefficient is 1. So this is a good time where you can try to pause this video and see if you can, work this one out yourself, and then you can get to the solution and compare. Okay, so here we go. 1 times negative 14, the first and the last number is negative 14 here. The middle number is negative 5. So what times what gives you negative 14 and that's negative 5 or 7 and 2? make the 7 negative because we need to add to -5. And so here are our factors, x minus 7 and x plus 2. Okay, let's take a look at number 4. Okay, factoring the polynomial. This is a trinomial, but you can see how it doesn't start with an x squared. It has an x to the third, it has an x squared, and it has an x. Of course, there's a 3 and a 30 and 75x. I'm going to try to factor out the greatest common factor first. So I see 3, 30, and 75. We can divide out a 3. We can also divide an x because they all share an x term. What that does, if we factor out a 3x, that leaves us with x squared. Factoring out negative 30x squared by 3x gives us negative 10x, and then plus 25. Again, in this step, you can just kind of distribute and see, do I get what I started with? I think it's a good habit just to check each step of the way. And so we have 3x and then x squared minus 10x plus 25. So this is a trinomial, or an x squared with an x squared. We're going to factor this now. The 3x is going to stay, and we're going to factor this into two separate factors. And here the last term is, here's 1x squared and the 25. So it's 1 times 25. Here's 25. And the negative 10. And we have what times what gives you 25 and adds to 10? Well, 5 and 5 does that. And because we need to add to a negative 10, they're both going to be negative 5. So we have x minus 5, x minus 5. Of course, you need to put the x there. I think I explained why, because x squared, you're going to split it up into x and x. And then you know the 25 you get from negative 5 times negative 5. How do we know it's negative 10? Well, the inside and the outside, the negative 5x plus the negative 5x is going to give us the negative 10x. Let's just simplify this fully. We have 3x, x minus 5, x minus 5. Condense that to 3x, x minus 5 squared. All right, so that's number 4. Let's go to the next type of factoring. Factoring the trinomial when the leading coefficient is not 1. So this is similar to number 4. Here, the leading coefficient, the number in the very front is 3. So what you want to do in that case, you always want to check whether you can factor that out first. So here in this case, 6x squared minus 23x and 21. The 6 and the 23 and 21, they don't really have anything in common. I can't factor out a 6 or anything else from that, these 3 numbers. So in this case, what we're going to do is multiply the 6 and the 21, first and the last terms. That's going to give us 126, I believe. Okay, and then we're going to write the middle term here, negative 23. And then what we need to do is think about what multiplies 126. And then adds to negative 23. So it's not very easy to do when it's big numbers like this, because I don't know what multiplies to 126 and adds to negative 3. Okay, so I worked this problem out and played around with my calculator. So here I know 126 can be split up into 9 times 14. But because I want to add to negative 23, I'm going to add negative 9 and negative 14. And so after we get these two numbers, what we need to do is split the middle term, negative 23x, into negative 9x minus 14x. Bring the last number down, plus 21, and then bring the 6x squared, the first term. Why we do it this way is where it's easier to factor by grouping when you have a leading coefficient that's not 1. And from 6x squared minus 9x, we group them and factor out the greatest common factor, which is 3x. What that does is it leaves us with 2x minus 3. And from, forgot to write the negative 14x there. From negative 14x plus 21, it's a negative. We're going to factor out a negative 7, leaving us with 2x minus 3 again. Here it's a negative because if you have a positive 21, we divide out a negative 7, you get a negative 3. Now we're going to just put these terms 3x minus 7 together and 2x minus 3 together. So if you're not sure again, your factors, just again check by FOIL using the box method. Okay, let's look at 5b together. We have 5b, 8x squared minus 10x minus 3. Same thing here, leading coefficient is not 1 and not 1, so we have 8, 10, and 3. There are no common factors, right, that they have. So we're going to multiply the 8 by the negative 3, first and the last numbers. Get negative 24, the middle term, the negative 10 down here. But what multiplies negative 24, and that's negative 10. That's going to be 12 and 2, with the 12 being negative. So we're going to use these guys and expand negative 10x into negative 12x plus 2x, then the minus 3 at the end. Don't forget about the 8x squared. Then factor by grouping. 8x squared minus 12x, they both have, let's see, 4x, giving us 2x minus 3, and positive 2x and minus 3. They don't have anything common, but you have to factor out something. So we have to factor out a positive or plus 1, 2x minus 3. And so let's just put these together, 2x minus 3 and 4x plus 1. So factors are 4x plus 1 and 2x minus 3. Okay, we'll move on to number 6. This is factoring trinomial with two variables. We have 6x squared minus 7xy minus 5y squared. And it's two variables because we have the x and the y terms. So in this case, you have the 6 and negative 7, negative 5. They don't got anything in common. So we're going to multiply the 6 with the negative 5. The first and the last numbers, negative 30. Think about what multiplies to negative 7. Sometimes it helps to do a factor tree. So 1 times 30, 2 and 15, 3 and 10. I think those are the factors. Let's grab 3 and 10. 3 and 10, and it looks like if we make the negative 10, positive 3 multiplies the negative 30, and then those two added together gives us negative 7. And so this we're going to split up into 3xy minus 10xy minus 5y squared and 6x squared. I'm actually going to do something called the reverse box method. And again, we could factor by grouping, but I just want to show you multiple ways of doing the problems. What you do is you make a box. And you put the 6x squared in the first box, and then plus 3xy, and the minus 10xy, and the minus 5y squared. And so all these terms go in the boxes. And what you're doing is in this row, checking to see, okay, what does this column have in common? So you can see they both have 6x squared minus 10xy. We can factor out a 2x. Now moving on to 3xy and negative 5y, what they have common is a plus y. Now we're moving to this row, 6x squared and 3xy. They both have a 3x in common. And then negative 10xy and negative 5y, they both have a negative 5y in common. Of course, it has to match up, right? 3x times 2x has to be 6x squared. 3x times y is 3xy. 2x times negative 5y is negative 10xy, and y times negative 5, it should have been a squared, is negative 5y squared. So these are going to be your factors. You have the 2x plus y, and 3x minus 5y. And you can always check by doing the FOIL process. Okay, factoring the trinomial when it's a perfect square. So we'll see what that means. What does that mean to be a perfect square? So in this case, we have, for this problem, 16x squared minus 56x plus 49. For this, because I'm kind of going to guess, I see the 16x squared I know it's a perfect square. 49 is a perfect square. And perfect squares, we're just doing a brief overview of what perfect squares are numbers. If we take the square root of, will give us a whole number, like square root of 16. We know it's 4, and square root of 49 is 7, because 7 times 7 is 49. So I'm kind of doing the guessing method here, put 16x squared, and thinking, okay, let me see, 4x. I break down 16x squared into 4x and 4x. And then 49 is 7 and 7. But because there's a negative, I'm going to try to see if we put a negative 7. And kind of doing a guess and check method here just to see, okay, does it give us negative 56? Remember the outside and the inside terms supposed to give us negative 56. So negative 7 times 4x is negative 28x. And then 4x times negative 7 is negative 28x. And if that adds together to negative 56x, we are good to go with the middle term. We got the 16x squared, we got the negative 7 times minus 49. So this simplifies to 4x minus 7 squared. So if you notice the first and the last terms are perfect squares, kind of just split it up into its perfect squares. And then you can check to see if the middle term works out. I think this is a quicker way than doing the 16 times 49, which would give us a really big number. Okay, let's take a look at 8a factoring 36x squared minus 25. So again, with this, if you have a perfect square and you're subtracting another perfect square, what this factors to, or factors out to, is 6x minus 5 and 6x plus 5. See, we don't have an x term. And that's because the inside term, which is negative 30x, and the outside term is positive 30x. They end up canceling each other out. So that's why you don't have an x term. So in general, the formula a squared minus b squared always factors out to a minus b times a plus b. So this is a handy formula to just memorize. If it were addition, we wouldn't be able to factor it, because if it were 36x squared plus 25, we say this polynomial is prime, which is just another way of saying can't be factored. Okay, last problem for today, 8b x squared minus 16. So again, this is a good time to pause and see if you can get this one on your own. So here we have x squared minus 16, so that becomes x and x. Negative 16 factors to negative 4 and plus 4, because these are both perfect squares and we are subtracting them. We have x minus 4x plus 4. So again, you can check by doing the FOIL process. Not every single time, but it's a good thing to check to see if your factors are good. Right, I hope this was a good overview of factoring. We went over some factoring problems together. And it's good to get some practice. Make sure you do get some practice right after reviewing this session.